Hello AP Stats students, Mr. Hazelhorst here with your first video for Chapter 2. Today we're going to introduce to you the concept of density curves and also give you a rundown of what Chapter 2 will entail. So sit back and enjoy. Here we go. The first big idea that we want to cover from Chapter 2 is that you can describe where an individual falls within a distribution by describing that score's location relative to the mean or median. And this idea of relative standing will be something that we refer back to time and time again as we work throughout AP Stats. Now, there's two common measures that we will use to represent relative standing. The first of which is percentiles, which will be a measure that locates things relative to the median, and then also z-scores, which represent things relative to the mean. And this is something that you'll be working on in class on Wednesday, so just kind of sit back and wait for that. The second big idea is what we're going to focus on more today. That for some distributions, it is convenient to describe the overall pattern by drawing a smooth curve rather than a histogram with many bars. And this is the idea of a density curve. And we'll give you an example of this in just a moment. But let's hit idea number 3 before we get into the idea of a density curve. The third big idea is that an area underneath a density curve represents a proportion of the observations from a distribution. So let's illustrate big idea number 2 and big idea number 3 through a couple of pictures and introduce this concept of density curves. So when we talk density curves, we're just simply talking about a mathematical model that represents a distribution. And it gives us a more compact picture of the data. And we're not worried about those minor irregularities or outliers. So in this screenshot that we see to the left, you can see that we've got an example of a density curve. You see the blue bars are representing the histogram, and that red line through that histogram is representing what we would call the density curve. Again, it's just giving us a basic picture of what that distribution looks like. Now notice there's parts where the bars extend beyond the red line, they extend outside of it, and there's also parts where there's a gap between the red line and the bars on the inside of that density curve. But again, we're ignoring those minor irregularities and just trying to get an overall picture of the distribution. So again, this is representing big idea number 2, that this is a convenient way to represent our overall pattern in a distribution. And this is something that we will use time and time again throughout AP Stats. Now, the picture on the right side represents big idea number 3, that when we find the area underneath the density curve, we're representing a certain proportion of the data that falls within that part of the distribution. So you can see here the blue shaded area in this right distribution, as the box says, the blue area represents scores that are less than 6. Right? So anything that's less than 6 is going to fall in that area. And we'll work with areas underneath the curve quite a bit here in Chapter 2. So that's a big concept that we want to keep in mind, all right? Is again, the area under the curve is representing a proportion of observations from the distribution that fall in whatever range we're looking at. So we'll get pretty good at shading things underneath the curve. That'll be an important step as we work throughout. All right? So let's talk a little bit more about density curves here and give you some more concepts involving them. So here we have a couple of characteristics that will be important to a density curve and things that we always want to keep in mind as we draw them and we use them in different situations throughout AP Stats. So the first characteristic is that the density curve will always is always on or above that horizontal axis. So as we draw density curves, the data itself will be represented on the horizontal axis, and the height of that density curve vertically will represent, the amount of data that fits within that specific value on the horizontal axis. All right, this is a very important concept that you will want to mark down. It's something that we will be reminded of time and time again. And that's that every density curve has an area of exactly 1 underneath it. So density curves will contain 100% of the data at all times. And so that's something that's very important that we'll use throughout when we do calculations with density curves later on here in Chapter 2. Okay? Now we've said this again, and we just want to keep reminding you of this statement, and it's that a density curve describes the overall pattern of a distribution. All right? And that area underneath that curve can be represented with intervals, and that's what we see here in this example. All right, we're representing the data from 7 to 8, and we're saying 12% of the data falls there because that's what proportion of the curve falls in that interval 7 to 8. So again, as we think about density curves, just remember they're going to have an area of exactly 1 underneath, and that different intervals within those density curves, we will use those intervals to find the proportion of data that falls within that interval. All right? Next big concept will be related to the mean and the median of a density curve. One of the things that we want to develop is the ability to recognize or approximate where the median and the mean will fall within a density curve. And so these definitions will be helpful to us as we think about that. All right, so when we talk about the median of a density curve, what we're referring to there is the equal areas point. So what that means is that's the point that's going to divide the data in half, meaning that 50% of the data will fall above the median and 50% will fall below the median. And so as you look at the diagram below here, the line, that black line that we see in all of these diagrams, that's representing the median. That's the equal area point. That's the point that, again, cuts the data in half. When we think mean, we want to think the balance point, and that's what our diagram down below is representing. You can see the triangle, that's representing different balance points. But when that curve is balanced, that's where our mean would be within that distribution, okay? And so we want to keep that in mind as we think about our distributions and we think about where the mean and the median will fall and relate to each other. That's something that we want to keep in mind. So again, the mean will always be pulled away from the median in the direction of a longer skew, all right? And so we mentioned this back in chapter 1, that the median and the mean are the same for a symmetric density curve, and then again the mean is going to be pulled in the direction of the skew. So we want to keep those things in mind as we work with density curves. Now a little bit more about the median here. Now this is just another example representing those concepts that we covered in chapter 1 and we're repeating here again in chapter 2. When we think about the median and the mean, as we can see in this diagram on the left side, when we have a symmetric distribution, those two are going to be equal to each other. But in the right diagram, we can see an example of a skewed distribution. We can see our median, all right, located right here, which again, that's representing the equal area point. So what that means is that 50% of the data falls above this value and 50% falls below this value. The mean, again, we want to think of as the balance point. So if we were going to balance this distribution, it would balance on that value of the mean. So we want to keep that in mind. Again, the mean and median will be approximately in the same place in a distribution that's approximately symmetric. Something that's perfectly symmetric, it will be right on top of each other, the mean and median will. And in a symmetric a skewed distribution, that mean gets pulled in the direction of the tail. So the example we have here is a right skewed distribution, so we can see the mean is to the right of the median. So those are important concepts that we want to keep in mind when we think about density curves, and again, how the mean and median relate to each other. Now our final big idea that we're going to discuss in chapter 2 is the idea of a normal distribution, or what's known as a normal curve. Normal curves are one of the most common types of density curves, and they're going to be something that we utilize a lot in AP Stats. We're going to have to make an assumption later on as we deal with statistical inference the second semester that a lot of times we are dealing with a normal distribution. And in an algebra-based statistics course like we're dealing with, normal curves are our most common type of density curve. And so normal curves are symmetric, they're bell-shaped, and their values or their shape are based on the mean and standard deviation, which is why back in chapter 1 we said ideally these are the values that we're going to work with. So we want to keep this in mind. Now this slide will be hit on more in video number 2, and then we'll also spend more time here in following lessons spending a lot of time here in chapter 2 working with normal curves. So this is something, if you've worked with them before, we're going to kind of expand probably on the knowledge that you have of normal curves before. If you've never worked with a normal curve before, don't stress too much about it. It's a pretty simple concept, but it's also foundational in statistics. It's going to be a very important concept. So chapter 2 here is a very important chapter as we think about normal curves and introduce this concept and begin to understand them better. So that brings us to the end of our Chapter 2, Section 1 video. So as always, I just want to remind you to complete the form below. Make sure you comment on that level of understanding and leave any questions that you have so that we can use that information to set up our lessons in class. But I hope you guys have a great day, and we'll see you soon. Bye.
Made with Doodlecast Pro.